Hello and welcome back to Physical Science Online. Today we're going to go over energy. Energy is our third topic of this year. And specifically, we're going to focus in on the first two BPs, mechanical energy and conservation of energy. As always, I'm going to aim for one video and probably plan for two because that's just talking about some of this stuff and doing a little bit of justice just takes a little bit of time. But that being said, let's dive in here. Definitions always needed. To be able to talk about energy, you first need to, this slideshow has a lot of stuff put in. You first need to know what energy is. We've gotten this one in a couple of our units already, since we've talked about energy a few times, the energy of chemical reactions, the energy of states of matter, the energy of motion we've briefly discussed a little bit already. So energy is the ability to do work. That one should already be in your notes at some point or another. But now we're going to get more into like transfers of energy and what energy is and how energy can be used. That's the real difference this time around. So energy can be transferred through forces that cause motion. Basically what we come down to. Energy will be measured in joules. Yes, get your laughter over with. I get maybe not as popular anymore, but that was one of our vaping, the original vaping craze at the high school level was the J-U-U-L, joule. Joules in science is going to be J-O-U-L-E-S, and it's going to be the measurement of energy. This is another unit where the units aren't going to cross out quite as nicely, and we're just going to say that energy is measured in joules, this term that scientists came up with instead of doing all the other crazy units that joules stands for. Everything has energy. If you have mass, you have energy. It's Einstein's famous equation, E equals mc squared. If you have mass, you have energy. If you don't have mass, you still might have energy. Everything that is not the absence of everything that's not just space has energy, and maybe even space does too if you go high enough in your science understanding. But so you want to think of everything as having some form of energy, be that active energy or stored energy or potential energy. There's a bunch of different types of energy out there. We've gone through some of them. We've talked about thermal energy. We've talked about chemical energy. We've talked about the energy of moving, kinetics. Kinesiology means moving. Maybe you've heard of electromagnetic and stuff like that. There's a lot of different forms of energy. This is just a brief list. Like these would be the top categories. There's some other categories, and then there'd be subcategories underneath these. The first one that we need to talk about, BP1, all about mechanical energy. So mechanical energy is, lots of animation season. The energy of motion or position. So moving or the ability to move due to its position, due to gravity is what we mean by position, especially for this unit. So you can think of something at the top of the hill having the potential to roll down the hill type stuff. Potential and kinetic energy. We'll get those in just a second. And basically, mechanical is just kinetic plus potential. So the car at the top of the hill that's already in motion has the potential to go faster without any chemical energy from the engine just because it's rolling down. So maybe bicycle, better idea, or rock, something that's not propelling it. Coming up with examples on the fly. Already in motion, but it has the potential to become more. You add them together and you get its energy. Rock sitting at the top of the cliff has a potential, but it's just sitting there. It's not actually in motion. Add them together, even though they're 1, 0, and you get its total mechanical energy. Same thing at the bottom of the cliff. No more potential, but it's in really big motion. Add them together, even though 1, 0, you get the total. Potential energy. Potential energy is, especially for this class, stored energy based on its position due to gravity. Which we're going to specifically look at due to its height, due to the force of gravity here on Earth. And that means that we're dependent on mass and position. Mass and height are 2 factors for potential energy. The more massive or higher it gets, the more potential it has. It kind of makes sense. Think of our roller coasters, how we had to start with them so high up to get them to move and do the loop-de-loops and everything. We'll reference our roller coasters a couple times in this unit. We get